doing is drawing a free body diagram of the forces on the scaffold. So look at the scaffold and then try and fill in all the values for the forces on the scaffold. Okay? Today is November 3rd. Yes, it is.
So close to Christmas.
Yeah. Okay. Since last period knows, I'll tell you. I know today's November 3rd because a very important person was born 63 years ago on this day.
Happy birthday, Miss Heather.
Thank you.
Thank you. Happy birthday to you. Happy birthday, dear Miss Heather. Happy birthday to you.
You got that on recording.
Thank you. Yeah. Thank you very much, guys. I appreciate it. All right. So with that in mind, okay, so we're going to go ahead. I'm going to go ahead and start working on this. So I'm going to draw the scaffolding as a point. Okay. So that's it. What's the easiest force that's on the scaffolding? Gravity. So I'm going to go ahead and draw force of gravity. I'm going to put a little S there, meaning scaffold. Okay. What other forces are acting on it? Yes, Kyle.
Tension with the cable, so you know.
Okay, so we're going to just do one cable at a time. So which one do you want to do, the left one or the right one?
Right.
Okay, so it's been decided for you. So we're going to do the force of tension from the right cable. So I'm going to call that the right. And then we're going to go ahead and do the force of tension from the left cable. So I'm going to like X that out and force of tension from the left. I'm stacking the vectors. Notice that's why I call stacking the vectors. So they're both acting the same direction, but I'm just putting one right on top of the other. And then I've got the scaffolding. Gravity's pulling the scaffolding, so I'm Xing that out. Is there anything else touching the scaffolding? Yeah. Tara?
The man's own normal force.
The man's own normal force. Well, the normal force pushes up, but the man is pushing down on it. So it's the force of gravity from the guy, his name is Burl, so force of gravity of Burl. Okay, so he's up. Anything else touching the scaffolding? The bucket, sorry. Thank you, Zach, for raising your hand. Okay, that's okay. Force of gravity of the bucket. I'm going to write it out because Burl starts with the B too. Okay, so first thing is I've stacked the vectors. There are some people who will put them, I'm going to do it way over here. Some people put those vectors like this and like that. I don't like that technique, so please don't do that in my class, but you might see them done like that in other classes. I don't like it because it's not very intuitive. So now we're going to put numbers to it. The force of tension on the left cable is 700 newtons. So we're going to put 700 newtons. Force of tension on the right cable is 500 newtons. So we're going to put 500 newtons. It says Bert has a weight of 600 newtons. So we're going to put 600 newtons. 600. And then it says the bucket has a weight of 100 newtons. So the force of the bucket is 100 newtons. Okay. What did I do wrong with the bucket and Bert? What did I not put on it? Yes, sir, no. Negatives. I need to put negatives on them. Okay. So they're negatives. And then I'm trying to find the force of gravity for the scaffolding. That's what I want to know. So if we remember, first of all, what kind of forces do we have here? Vertical, horizontal, or both?
Vertical.
It's just vertical. It's not both. It's just vertical. Okay, so I've got that equation, F net is equal to the sum of the individual forces, and the only forces are vertical forces. I'm going to write it way down here. So I'm going to write, so F net is equal to the force of tension from the left rope plus the force of tension from the right rope plus the force of gravity of the scaffolding plus the force of gravity from Bert, or Burl, it is Burl, from Burl, plus the force of gravity from the bucket. Okay? So we don't always just have like two forces. Sometimes we have lots of forces. Okay? And now we can start putting numbers in. Net force. We also know the net force is equal to mass times acceleration. Is this scaffolding accelerating? No. So if acceleration equals 0, then from the formula F net equals mass times acceleration, we know that F net is equal to the mass of the scaffolding, whatever that is, times 0. So F net is equal to 0, because anything times 0 is 0. So I can start filling in numbers. I've got a 0. The force of tension on the left cable is 700. On the right cable is 500. The scaffolding, I don't know. Burl is negative 600, and the bucket is negative 100. So from all that, is it pretty intuitive what the force of gravity on the scaffolding is? Yeah, it's negative 500. So the force of gravity on the scaffolding is equal to negative 500 newtons. Okay, so one of the things I liked about this bell ringer is that it showed you stacked vectors. And the other thing is that we've got just a whole bunch of different things. So we don't always have just two vectors in a y direction or just two vectors in an x direction. On the easy problems we do, but we could have more vectors. If you have more vectors, you stack them. Okay? So let's get your notes out. Let's do the next one in the notes. So Brett places a 10-kilogram wagon on the sidewalk and puts his 15-kilogram puppy in the wagon. He pulls the wagon with a force of 50 newtons, and friction opposes the pull with a force of 40 newtons. So first draw a free body diagram of the wagon. So draw that free body diagram of the wagon. So go ahead and start drawing it in. Okay. Oops. Sorry. Easiest one is the force of gravity. Anybody want to give me a technique for finding the force of gravity? Mia, what am I going to do? What's the formula for force of gravity? What's another name for force of gravity? Weight, right? Okay, so what's the formula for weight? Mass times little g. Okay, what mass do we have?
15 kilograms.
Well, we got 15-kilogram puppy. What's the puppy sitting in? So it's total at 25. And what's little g on Earth? 9.8 newtons per kilogram. So that number comes up to, somebody want to calculate it? I forget, I think it's like 1.
49. Or, whoa, hold on. 245.
245?
Yeah.
And it's a negative, right? Because it's going downward. Let's see if I can erase here. Yeah, I can. Good. Equals. Okay. Is the wagon and the puppy sitting in the wagon? Is it sitting on a surface?
Yeah.
Yeah, if it's sitting on the surface, then we also have a normal force, right? And then we have that applied force, that's pulling of the wagon. So he's pulling it with a force of 50 newtons. And then we have this frictional force that opposes the pull. So the frictional force would be this way, and the frictional force would be 40 newtons. And what do I have to do with that 40 newtons? Make it negative because it's going the opposite direction. Okay. For everybody else, I showed a very complicated technique on how to figure out what the normal force is. Let's just talk it through. Okay, is the wagon all of a sudden accelerating up off of the sidewalk? Is it sinking down into the sidewalk? So what is the acceleration of the wagon in the vertical direction? 0. So the net force in the vertical direction is 0. So what is the normal force? No. It's 245 newtons, yes, because it has to cancel out the force of gravity. Okay? The net force is 0, so that means the two individual forces have to cancel out. Yes, sir?
Does it matter which way you put the applied force and friction on?
Not really. I just tend to make friction negative because it's a negative thing to me.
Yeah, but like, does it matter which side you put them on?
No. It doesn't matter if they're opposite? Yes.
Okay.
So they have to be opposite,
Yeah.
but it doesn't really matter. I'm just telling you, I'll probably always draw it like that. If you draw it backwards, it's okay as long as you can convert.
Okay.
Right? Now, on a test, it'd be fine. You'd have a negative number where I'd have a positive, and I would just figure it out. Okay? So now we draw the free body diagram showing vertical. Find the net force in the vertical direction. We already did. We talked through it. So we said that that was equal to 0 newtons. Find the net force in the horizontal direction. So horizontal, we're going to look at, We're going to look at F net is equal to the sum of the individual forces in the horizontal. So I'm looking at x's. So F net x is equal to the force of friction plus the applied force. Okay, so F net x is equal to negative 40 plus 50, which is equal to 10 newtons. Okay. That makes sense? Then the next one is, we did this, what is the acceleration of the wagon? So then acceleration, we've got another formula that's not kinematics, it's Newton's second law. F net, and we're just talking about horizontal, so x is equal to mass times the acceleration in the horizontal direction. And if you don't want to put those x's in there, it's okay as long as you realize you're just talking horizontal. And so we're doing 10 newtons equals the mass, and the puppy and the wagon is 25 kilograms times acceleration. Rudy, do you have that number? 10 divided by 25? .04? .4?
Yeah.
Thank you. All right. We good with that? Okay. Because I'm going to run out of space here, I'm going to erase my free body diagram. But notice how easy all this stuff over here was if you had a good free body diagram. So the free body diagram really helps you to solve the problem. So let's erase the free body diagram if I can. Okay. And now I want to find out how long does it take. So I want to find time, and the distance is equal to 20 meters. If I start throwing time and distances in there, now I'm start looking at the kinematic equations. So I want a kinematic equation that has a distance, a time, acceleration I know, so I can have acceleration. DI is always 0, and in this case, if we start pulling the wagon, what's our initial velocity? 0. So we know we can infer that VI equals 0, and we can always infer DI equals 0. I want to find a kinematics equation, and I want to be lazy. I just want to do it once. So find me a kinematic equation I can use where I can get all that. I can find the time using distance, VI, DI, and acceleration. The second one sounds good. So I'm going to use the second one. DF equals DI plus VIT plus 1/2 AT squared. So I've got 20 meters is what I know. So I'm going to go 20 is equal to 0 plus 0 plus 1/2 times 0.4 times T squared. T equals 100. T squared equals 100, and T equals 10 seconds. Everybody good? Okay. Let's try another. Okay, move this slide on. Another minute. Okay, it's going to go now. Okay. So we're going to do this one. Jenna decides to put her brother Brett in a 10 column wagon and pull him. He insists that he wants to accelerate at 0.2 meters per second squared. Brett has a mass of 32 kilograms. Friction for the wagon is 40 newtons. How hard does Jenna have to pull? So I want you guys to go ahead and draw a free body diagram showing horizontal and vertical forces. Try and find the net force in the vertical direction, the net force in the horizontal direction, with what force does Jenna have to pull, and after pulling for an exhausting 4 seconds, how fast is the wagon of Brett going? Get the information written down fairly quickly, because then I'm going to make this go away for a minute so I can make the slide look better, so I can draw on here. Okay, I'm going to take it off now for a minute so I can...
Just put it right over here.
Yeah, thank you.
Avoid
Actually, let me put it away pretty quick. Yeah. So it's a real powerful magnet, and it messes things up.
I got 411 points.
Yeah, did I goof up? Probably. It's 42, right? Yeah, I don't know what I did. Thanks. Okay, what do I do next? Okay, how do I find the net force in the horizontal? Kyle.
Do mass acceleration.
Yeah, so I can do F net equals mass times acceleration. Okay, and so we got the 0.2. Okay, what am I going to do next? Okay, I've used this formula, right? So what's the other formula? Yes, ma'am. Yeah, so F net is equal to the sum of the individual forces. We're just talking horizontal, so F net is equal to force applied plus force of friction. And it doesn't really matter what order you put them in. I always kind of mess around. So I have F net from up here, so I'm going to put that in, 8.4. Okay, force applied I don't have. And force of friction I have, so that's a negative 40, so I'm just going to erase the plus and make it negative 40. Okay. So force applied is equal to 48.4 newtons. So now I can erase that and say it's 48.4 newtons. Okay. So on the next one, I'm talking about time. So I've got t equals 4 seconds. I'm hunting for a VF. So I'm probably going to be using my kinematic equations. Again, we can assume or infer that VI equals 0 and DI is always equal to 0. What kinematic equation am I going to use? I've got an acceleration. Acceleration is 0.2 meters per second squared because that demanding little brother says it must be 0.2. So what equation am I going to use? The first one is so easy. VF equals VI plus AT. And 0.8 meters per second is not terribly fast, but on the other hand, the little kid's being a brat, so what the hey. Sorry, I had two younger brothers. Okay, so what I did for the other classes is I gave them a very hard worksheet so they could see really, really hard problems. And then today, because fourth period's ahead of first and second period, I gave them an easier Moodle assignment. I think I'm going to give you guys the easier Moodle assignment. Okay? So, Moodle, let me try and find it for you. Does everybody have everything they need here? If not, grab it from somebody else because I'm going to get rid of the... Okay, so I don't have a picture up there yet. I probably will by tonight. Forces in one dimension is where we're at. Forces in one dimension. And it's forces 2. Okay? So, and 25 people have already done it. So go ahead and go in there. These are easier. They're from Mr. Ringenberger and Mrs. Penoff. And so they have them as squares instead of dots. They have the free body diagrams drawn. And you're just going to be answering questions. You need to show work. I don't have the Moodle worksheets out, but I've got WebAssign worksheets. You can borrow those. Because when Mrs. Penoff does these, she has like the first question, then she has a series of questions that depend on that first question. So you can just write question number 1 and show all the work for questions 2 and 3 under question number 1. Does that make sense? And then the same thing for the next grouping. So you don't have to, you'll see you have question number 4 and then work for 5 and 6. So you've got repeat work in there. You don't want to redo it. Okay, that's all I've got. You can do work on your own sheets if you'd rather instead of using my sheets. That's fine. Thank you very much.